Welcome back to the Deep Dive. We take complex sources and, well, distill them into the high-impact knowledge you need. Today we are tackling a really crucial skill set for this AI era, prompt engineering. Basically the key to getting the most out of large language models, things like ChatGPT.
Yeah, absolutely. If you're using these tools, I mean, the difference between getting something frustratingly generic back and getting a perfect, actionable result, it really all comes down to how well you communicate with the model.
It's not just typing better,
Oh,
right?
go
It's like
for
a
it.
whole new kind of communication skill.
Exactly. Mastery, really.
And the money involved here is pretty staggering. Our sources pointed out this fascinating fact. Companies are paying up to $335,000 a year, that's according to Bloomberg, for people who are good at this. And the really interesting part, often you don't need a traditional coding background. It's more about, like, linguistic and logical thinking.
That's spot on. So our mission today really is to give you the strategy and maybe more importantly, the mindset that, that justifies salaries like that. We'll dig into why some prompts work way better than others.
Okay.
We'll cover the difference between, say, few-shot and zero-shot prompting, and then we'll kind of crack open the hood a bit on things like tokens and text embeddings so you actually understand how the AI is, well, how it's hearing you.
All right, let's unpack that. Starting with the job title itself, prompt engineer. What does that role actually involve beyond just, asking good questions?
Well, it's definitely more than just asking questions. It's a continuous strategic thing. At its heart, yeah, it's writing, refining, optimizing prompts to get the best output. But those big salaries, they're not just for writing one clever prompt.
Really?
They're really paid for system maintenance.
System maintenance. Okay, that's the key phrase there. What does that mean day to day? The continuous part.
So a professional prompt engineer, they have to constantly monitor how effective the prompts are. Because these LLMs, they get updated, they sort of drift, their baseline behavior changes, sometimes subtly.
Ah, so an old prompt might just stop working as well.
Exactly. You've got to anticipate that drift, correct for it. And you're also maintaining this version-controlled library of prompts. Think of it as a database of tested, reliable scripts for all the important business tasks.
Okay, a whole library.
Yeah, and it also involves dealing with risks like prompt injection, where someone tries to trick the AI into breaking its own rules. It's actually pretty complex problem-solving, high-stakes stuff, not just typing.
That makes total sense. It's like quality control and security, but for the AI interaction layer.
Oh.
Which brings us nicely to the mindset you need. The sources used a great analogy comparing good prompting now to effective Google searching 10 years ago.
Oh, that's an excellent analogy, yeah. You need precision right from the start. The goal is to write one killer prompt, one that hits the target perfectly, saves resources, saves time, saves compute power.
Instead of having this vague, long back and forth where you try asking 5 different ways.
Exactly. Wasting time and tokens.
So before we dive into specific strategies, maybe let's quickly clear up some tech terms. We hear AI and machine learning, ML, used almost interchangeably sometimes. What's the practical difference people should keep in mind?
It's a good distinction to make. Artificial intelligence, AI, that's the really broad idea, the simulation of human intelligence. But when we talk about tools like ChatGPT, we're usually talking more specifically about machine learning, or ML.
Which is a way to get to AI.
Right. ML uses these absolutely massive data sets for training. It finds correlations, patterns, and then it basically predicts the most statistically likely outcome. It's pattern recognition, just on a huge scale. It's figuring out what words or ideas are most likely to come next based on everything it's read.
Got it. So it's like a superpowered prediction machine trained on, tons of human language.
Yeah.
And speaking of language, this is where it gets really interesting for me. The foundation of all this is linguistics. Why is understanding language structure so vital for a top-tier prompt engineer?
Well, because the AI is fundamentally processing language structure and context. You don't need to be a linguistics professor, studying phonetics or anything. But understanding syntax, how sentences are built, and pragmatics, how context changes, meaning that's everything. If you use standard, clear grammar structures that are common, the AI is just much more likely to give you accurate results. Why? Because its training data is built on those same conventions.
So the feedback loop. We talk to the system effectively by using the rules the system itself learned from.
Precisely. And, this ability didn't just appear overnight. The history of conversational AI actually goes way back to the 1960s with a program called ELIZA.
Ah, ELIZA, the original digital therapist, right? Created by Joseph Weizenbaum at MIT.
That's the one. ELIZA basically mimicked a Rogerian psychotherapist. It used clever pattern matching. It didn't understand you, not really. It just spotted keywords and sort of reflected things back using predefined templates.
So if you typed, like, I'm feeling sad today,
It might respond with something like, "Why do you say you're feeling sad today?" Simple mirroring.
but the key finding was amazing, wasn't it? People knew it was just code, but they still projected human feelings onto it. They felt understood.
That finding is so crucial. It tells us so much about our own human tendency to, well, anthropomorphize, to see intention in communication. That early work really paved the way. Later you had systems like Shidlu in the 70s, but the real language model revolution that kicked off around 2010 with deep learning, which led us to the GPT family.
GPT generative pre-trained transformer?
Yep, we saw GPT-1 in 2018, then GPT-2 in 2019, and then the real game changer, GPT-3 in 2020. That thing had over 175 billion parameters. That was the moment people realized, wow, scale really does lead to new abilities.
Emerging capabilities.
Exactly. And now, well, now we have GPT-4, trained on what some sources just call pretty much the whole internet. We've gone from simple reflection to something much more like sophisticated comprehension.
Okay, so let's pivot to the practical stuff. How do we actually do this? The biggest mistake people make is just treating it like a simple search query, right? Like, correct my paragraph.
Right. Effective prompting needs structure, strategy. Strategy number 1. Be absolutely clear and provide details. This is critical, not just for quality, but also for managing your token usage and saving time. You just can't assume the AI knows your specific context.
Give us an example of that precision.
Okay, so a bad prompt would be, when is the election?
Vague, right. The AI has to guess which election, which country. It'll probably ask you follow-up questions.
Not wasting time and tokens again.
Exactly. A killer prompt is, when is the next presidential election for Poland? Precise. You get the right answer straight away. And this is huge for coding, too, instead of just write code for validation.
Each could mean anything. Right. You specify. Write a JavaScript function. It should take an array of objects. Filter that data based only on whether the age property exists. Give me the function and a short single-paragraph explanation how it works. See the difference.
Totally. That level of detail. And specifying the explanation, too. That precision in structure leads right into strategy, too. Telling the AI the format you want back.
Yes. Never assume it will give you the output in the format you need. If you want a checklist, ask for a checklist. If you're summarizing something dense, don't just say, summarize this.
Be more specific.
Way more specific. Like, use bullet points. Explain the 3 main arguments in this essay. Make sure each bullet point is no more than 10 words long. You're essentially dictating the constraints of the final output.
Okay, strategy 3 is my favorite, I think, because it feels the most transformative. Adopting a persona. Giving the AI a character.
Ah, yes. This is where you really start leveraging the AI's training data to create a more interactive, consistent experience. Let's say you're learning English. Don't just ask it to correct your grammar.
What should you do instead?
Ask it to. Act as a strict, spoken English teacher. Limit your reply to 100 words. Correct my grammar rigorously, and ask me one follow-up question in your response.
Suddenly, it's not just transactional. It's an ongoing, engaging collaboration.
That completely changes the interaction. And you can get really creative with this for complex tasks too, right? Like guiding the style.
Absolutely. Let's say you want a poem, a really good one. Don't just say, write a love poem. That's going to be generic.
So layer the persona.
Exactly. Specify the constraints that tap into its training. Write a poem in the voice of a 25-year-old character. Her name is Helena. She's an accomplished writer, and her writing style should mimic the rhythm and tone of the famous 21st century poet Rupi Kaur. You're giving it a detailed blueprint for a specific style.
Wow, so you're guiding it away from generic output towards something really specific, personalized, and potentially much higher quality.
Precisely. You're maximizing the value you get back. Okay, and just to quickly wrap up the other best practices we found. Remember iterative prompting. That means building on the conversation, like asking 4 + 4. Then using the answer 8 in your next prompt. And also try not to lead the answer. Don't put your expected result into the prompt itself, because that can bias what you get back. Right, let's move into some of the more advanced concepts now. How about guiding the AI using its existing knowledge base? Zero-shot versus few-shot prompting.
Okay, so zero shot is basically the default mode. It's when you rely entirely on the model's pre-trained knowledge. You don't give it any extra examples in the prompt itself, asking, what is the capital of Peru? That's zero shot. The model just knows that from its training.
Makes sense. So few shot is where the real engineering comes in, providing those examples.
Exactly. Few-shot prompting is about enhancing the model's response by feeding it a small, specific set of example data right there in the prompt. This helps steer its interpretation or prediction for your specific, immediate need.
Can you give an example of that?
Sure. Let's say you input something like, Anaya prefers sweet and savory foods. Think gourmet burgers, fries, pizza. Here are her last 5 favorite meals. You give it that context. Then you ask, based on this, what restaurant should I take Anaya to in Dubai this weekend?
Ah, so the model isn't just using its general knowledge of Dubai restaurant.
Right. It's using that temporary custom data you just gave it about Anaya's preferences to generate a much more tailored, relevant answer.
Okay, but wait. If I'm stuffing all those examples about Anaya's food preferences into my prompt, isn't that prompt going to get much longer? I mean, I'm using more tokens just for the input before I even get an answer back. Is that extra cost always worth it?
That is the core engineering trade-off you're constantly making. For really simple tasks, probably not worth it. But for complex things, maybe classifying data accurately, generating sophisticated code, or doing critical creative work, that huge boost in accuracy and relevance you get from few-shot, it often far outweighs the small extra cost of a few input tokens.
So you pay a little more upfront in tokens.
To guarantee you get the high-quality result you actually need instead of wasting time on bad outputs.
Gotcha. Speaking of accuracy, or lack thereof, we have to touch on AI hallucinations. What exactly are those and what causes them?
Hallucinations are basically, well, they're like educated guesses that go wrong. They happen when the AI model misinterprets patterns in the data, especially if there are gaps in its training. It might make connections that seem plausible but are statistically unlikely, or it just fills in the blanks with information that sounds confident but is totally inaccurate.
Like Google's Deep Dream, seeing dog faces everywhere in clouds.
Exactly. Or text models that just make up historical facts or citations that sound convincing but aren't real. It's trying to complete the pattern, but it gets it wrong.
And precision in prompting is our best defense against that.
Okay, let's talk about the technical thing that underpins efficiency.
Tokens.
Right, tokens. They're the fundamental unit the AI works with. LLMs don't see words like we do. They process text in these chunks called tokens. For English, think of a token as roughly 4 characters, or maybe 3/4 of a word.
And why do they matter so much?
Because everything is measured and usually charged by tokens. Your input prompt, the AI's output, every API call. So being clear and concise in your prompts isn't just about getting better answers faster. It's literally about saving resources, saving money. Efficient prompting is efficient resource management.
Okay, final piece of the puzzle. Let's get into the really deep technical why. How does the LLM actually process our words to understand meaning? This is where vectors and text embeddings come in, right?
Yes, and this is maybe the most crucial concept if you really want to understand how AI comprehends. See, a computer can't work with words directly based on meaning. It only understands numbers. Text embedding is the process that converts your prompt individual words into a high-dimensional vector.
A vector being like a long list of numbers.
Exactly, a massive array of numbers. But
Yeah.
this array isn't random. It captures the semantic relationship of your text, the meaning behind the words.
Semantic meaning. So the concept, the idea, not just the letters CAR.
Precisely. Think of it like a huge, complex city map where every concept is a location. Embeddings make sure that the point for car is located really close to truck and commute because they're related in meaning. But it's miles and miles away from cabbage, even though they both start with C.
Because the meaning is totally different.
Right. The distance on this map is based on shared meaning. And that's what allows the LLM to grasp context, understand complex relationships between ideas, and give you relevant, meaningful responses back. It's translating our language into the language of computation.
Wow. Okay, so tying this all together for you, the listener, what are the big takeaways? We've established prompt engineering as a seriously valuable skill. It needs a specific mindset, almost like system design. It requires mastering these best practices using personas, specifying formats, knowing when to use few-shot examples. You're shifting from just being a user to being like a fluent guide for the AI.
And maybe let's bring it right back to where we started. With ELIZA. Remember Joseph Weizenbaum? He was genuinely shocked that people saw human feelings in his simple pattern matching program back in the 60s.
Right.
Now here we are, deliberately engineering these really complex, personalized interactions like getting that Rupi Kaur-style poem or the hyper-specific restaurant recommendation for Alanaya. We're crafting nuance. So the provocative thought I leave you with is this. Live in how sophisticated these LLMs are becoming and how precisely we can now tailor interactions using these techniques. How quickly is our collective view going to shift? How long until we stop seeing them just as tools and start seeing them as, well, increasingly sophisticated, maybe even indispensable collaborators?
Definitely food for thought. So go try these strategies out in your own LM interactions. See the difference it makes. Enjoy the collaboration. We'll catch you on the next deep dive.